Hello, my dear pupils. Welcome back in Unit 1. We'll study together Lesson 3, Ordering and Comparing Natural Numbers. As we mentioned before, natural numbers denoted by the capital letter N. The set of natural numbers equals 0, 1, 2, 3, and so on. We have many subsets of the set of natural numbers. These subsets are what? Are C, counting numbers, even numbers, odd numbers, and prime numbers. Okay, we will now order and compare any two natural numbers. Actually, to do this, we have to use something called a number line. What's the number line? The number line is a line, and we write the numbers in order on this number line. And we leave equidistant between each point and the other. So all these points have equidistance between each point and the other. We can use our graph copybook in this lesson to draw many number lines. Okay, let's see, for example, this number line. We want to express the points 0, 1, and 5, and 8 on the number line. We want to express this set on the number line. So, draw the number line in your graph copybook and put the numbers in order on this number line. So, we write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. The number line has no end. We want to denote the points 0, so we draw a circle here and we shade it on 0. 1, we also draw a circle and make a shading for it on 1. 8, we make another circle here and we make shading for it. 5. So we denote these points on the number line. Let's take another example. We want to denote the set of even numbers on the number line. So even numbers equals 0, 2, 4, and so on. So let's write the numbers in order on the number line. We write all the numbers on the number line. And this is infinite numbers. We want to denote 0, 2, 4, and so on. So we do it like this. We make shading here on 0, and 2, and 4, and 6, and we start to make a line like this, and this line has an arrow because this set is infinite set. Let's see these words. When we order natural numbers, we say 0 is smaller than 1, and of course it's smaller than 2, and so on. And we also say 7 is bigger than 6, is bigger than 5, and so on. Let's see this example, and this example is very important example. Let's compare any two numbers on the number line. And now we'll give this number a symbol called A, B, C, D, E. Of course, the numbers comes first. For example, A is smaller than B. If we give the number line a number here, 1, 2, 3, 4, and so on, the A will be smaller than B, and C will be bigger than B. So let's see how can we solve this? A and C. A and C. A comes first on the number line. So A is smaller than C. Okay, we have E and B. E and B. E is bigger than B. F and A. F is here. So F and A. F, of course, bigger than A. B and F. B here and F here. So B is less than F. B any number on the number line. So it comes first on the number line, so it's smaller than the next number. C and E. C and E. C comes first on the number line. So C will be less than E. B and D. B and D. B comes first on the number line. So B is less than D. Okay, let's see this definition. Two different natural numbers are called consecutive natural numbers if there is no natural number between them. The word consecutive is very important word. Consecutive means comes after each other. For example, the number 3 and 4 are called consecutive numbers. For example, the number 10 and 11 are called consecutive numbers. Okay, I will ask you a question now. Is the two numbers 17 and 19 consecutive numbers? No, they are not consecutive numbers because there is 18 in the middle. Okay, we also have another thing. If we say that we have the set of even numbers 0, 2, 4, 6, and so on. We say that 4 and 6 are two even consecutive numbers because there is no even number between them. So when we say two even consecutive numbers, we say 4 and 6 or 2 and 4 or 6 and 8. Okay, let's see the set of odd numbers. The set of odd numbers 1, 3, 5, 7, and so on. We say that 3 and 5 are two odd consecutive numbers. 1 and 3 are two odd consecutive numbers. Okay, let's see this example. If x is a natural number, any natural number, then the three consecutive natural numbers comes after it. So the three consecutive numbers comes after x are, yes, comes after x. So the natural numbers comes after x are x plus 1, x plus 2, and x plus 3 because we add 1 in each time. If y is a natural even number, take care about the word even here. Then the three consecutive even numbers just come after it, even numbers, so we drop 1 in the middle. So we say y plus 2, y plus 4, and y plus 6 because they are all even numbers. The next one, a man of y years old, where y belongs to n, that means y is a natural number. Then his age after 7 years. So his age now is y years. After 7 years is y plus 7. His age 7 years ago. 7 years ago means y minus 7. Now, I want you to open your school book, page 9, and try to solve that with me. Write the following sets using the listing method. I will explain the first two for you, and you can try to solve the next two ones alone. The first one is x equals a such that a belongs to n, where a is between 0 and 4. So we can read this like that. X equals A such that, these 2 points means such that A belongs to N, where A is between 0 and 4. So we can write it by listing method as between 0 and 4, we don't take 0 or 4. So we take 1, 2, and 3. And we can represent it on the number line. Of course, in our graph book, we can draw our number line. And we write here 0, 1, we leave equidistance We take the big squares in our graph copybooks, 4, 5, and so on. So we take 0, we take 1, and 2, and 3. We draw it like this. The next one, y equals a such that a belongs to n, and a greater than 3. What's the numbers greater than 3? 4, we don't take 3 with us, 4, 5, 6, 7, and so on. How can we represent this on the number line? We draw our number line in our graph copybook, and we draw 0, 1, 2, 3, 4, 5, and so on. And the numbers bigger than 3 will be 4, 5, and we make a line like this, and we make an arrow to take all the numbers after 3. Okay, write down these numbers represented on the number line. As we see here, the numbers denoted on the number line, 1, 3, 5, and 6. And the numbers denoted on the next number line, 0, 2, 4, 5, 6, and so on. And the last one is 5 on. Okay. I will remind you with this one, the set of prime factors of 30. How we write the set of prime factors of 30? We have two ways. The first way, we factorize 30 by the way of the stick. We divide it by 2 equals 15, by 3 equals 5. 5 divided 5 equals 1. And we take all the numbers on the left and the right. These are the factors of the number 30. So the set of factors of the number 30 are 30, 15, 5, 1, 2, 3. We multiply this, 6, and 10. So these are the factors of the number 30, and we can represent it on the number line. Or we can do another way. What's the other way? The other way, you write 30 equals what times what? 30 equals 30 times 1. 30 equals what also? 6 times 5. 30 equals 2 times 15. 30 equals what also? 3 times 1, 6 times 5, 2 times 15, and what else? And 10 times 3. So we take all these numbers, and all these numbers are called factors of the number 30. So that's the factorization, and we take it in primary 4. Now, I want you to solve your booklet, page 4, 5, and 6. Thank you.